So how do we graph a quadratic equation? Well, first of all, you need it in vertex form. An example of vertex form would be x minus 2 quantity squared plus 1 equals f of x. Sometimes you might have it in standard form like x squared plus 2x plus 1 equals f of x. You need to change this into vertex form. If it's not a perfect square, you need to complete the square and then change it into this. I have a video on that. So we're going to just look at examples where our quadratic equation is in vertex form. So the most basic parabola, which is what a quadratic looks like as a parabola, is y equals x squared. This is the parent graph, and it looks like this. It's centered at 0, 0. This is called the vertex. There's a few things that can happen, though, and modify this graph. We can move it up or down, left or right. We can make it steeper or less steep, and we can also flip it over the x-axis. So let's take those one by one. What if I have y equals x squared plus 1 on the outside? What is happening here? All of my y values are being increased by 1. So if my y value was 0, it's now 1. If it was 0.2, it's 1.2. So the shape of your graph has not changed. The only thing is it is shifted up 1, and it is now 0, 1. If this was a negative 1, then your graph would be shifted down, and it would be 0, negative 1. And these are just rough sketches. Assume that they're all to scale. Okay, what if we have y equals x plus 1 on the inside of the square? This is a shift left or right. If it's on the outside of the square, you're shifting it up or down. If it's on the inside, you're shifting it left or right. Intuitively, you would want to think, oh, it's a plus 1, so am I moving to the right? But actually, you're moving to the left, and I get this right here, negative 1, 0. To figure out what shift it is, left or right, you want to think what makes this whole thing equal to 0, and the answer would be negative 1, so I'm moving to the left to negative 1. It's the opposite of what you would probably expect. It's a plus 1, you want to think you're going to the right, but for shifting left and right, when it's inside the square, it's the opposite of the sign. So if this was a x minus 1 squared, I would be moving to the right by 1. What if I have a number in front of my x squared? This is multiplying every single value by 10. It's not changing the location of the vertex. It's just changing how fast my graph is increasing. Every single value is being multiplied by 10, so I'm going to get really steep really fast. If this number in front of your x squared is greater than 1, if it is greater than 1, it's going to increase your steepness of your graph. If it's less than 1, like let's say if this was 1/2 of x squared, well now all your values are being multiplied by half, so you're going to get higher slower, so it's going to decrease the steepness. The final thing that you can do is have a negative in front of it. Initially, y equals x squared looks like this, but this negative is making every single value, every single y value, a negative. It's turning it into the opposite. So actually the graph looks like this. It's flipped over the x-axis. So let's do some examples and incorporate all of these changes. What if I have y equals x minus 1 inside the parentheses plus 1? So here I notice I have a shift up or down, which in this case is up, and I have a shift left or right. In this case it's right. Remember, when you're shifting left or right, it's the opposite of whatever sign you have, because you want to see what makes this entire parentheses equal to 0, and the answer would be positive 1. So I'm going to go to the right 1, and I'm going up 1. So my vertex is at 1, 1, and the shape of the graph is the same. It hasn't been, this is just a rough sketch, but I don't have any multiple in front of here, so it's not increasing or decreasing the steepness. What if we have y equals negative x minus 3? Let's make it a plus 3 squared minus 2. So here I notice I have almost every change possible. I have a negative, so I know my graph will be upside down. I have a plus 3, which means I'm moving to the left by 3. 1, 2, 3. And I have a negative 2, which means I'm moving down 2. So my vertex is here at negative 3, negative 2. And it's a negative in front of my parentheses, so my graph is going to be upside down looking like this. Sometimes you might be asked to find the zeros of the graph. The zeros of the graph is where your curve, intersects the x-axis. As you can see here, it's never going to intersect the x-axis because it's below the axis and it's facing down. If I have y equals x squared minus 2, this graph is just a regular parabola, but it's shifted down 2. And so the vertex is 0, negative 2. I am hitting the axis here. Now, if you were to figure out where you're hitting the x-axis, well, at both of these locations, my y value is 0. The x-axis, on the x-axis, your y value is 0. You haven't gone up or down. So I can just solve this quadratic equation by setting my y equal to 0. So I have 0 equals x squared minus 2. And so my x would be plus positive 2 or negative 2, because I have one on the left, one on the right. Let's do a couple more graphs. So what if I have y equals 3x squared minus 4? Let's make that a negative 3x squared. So I have a negative, which means my graph will be upside down. I also have a negative 4 on the outside of the square, which means I'm shifting down by 4. It's a negative 3. All that means is that my graph is going to get steeper faster because everything is being multiplied by that 3. And it's negative, which means I'm going to be facing down. The vertex is 0 because I haven't shifted left or right any, but I have shifted down 4. This multiple in front of your x squared, in front of the parentheses, does not affect the location of the vertex. It's only affecting how steep or how not steep your graph is. If I have y equals 0.1 times x squared, this graph is it's increasing, but it's very slow. So it's going to be wider. You can think of it that way. If this was 15 instead, without the decimal, then my graph would be increasing very fast. So it would be almost vertical pretty quickly. And remember, this is in vertex form. If it's not in vertex form, you need to convert it into vertex form. And the previous example here, this is not in vertex form. I need to factor this. This turns out to be a perfect square. X plus 1 squared is equal to f of x. So this one right here is ready to graph. If it's not in vertex form, if it's not a perfect square, then you need to complete the square to get it into vertex form. And I have a video on that you can check out.